right, removing discontinuities. Find the value of a that will make the function continuous. So this particular problem, again, the domain is what you got to really understand. Domain. It's saying that x not equal to -1 is this, and x equal to -1 is this y value, this output. It's an output. So this is a rational function here, no? You know this is a rational function, and if you plug in x is equal to -1, that'll be -1 plus 1 is 0. That's why it's saying x cannot equal to -1. But why don't we just factor this and get rid of that problem of x cannot equal to -1? Let's factor this out. So the bottom is a set. I'll go with x plus 1 as a set. And then this one can be factored out as, let me go here, x and x. And what are the numbers? So easy. What are numbers? What else could it be other than what? 2 and 1? Yeah? 2 times 1 is 2. 2 plus 1 is 3. And now what can we do there? Cancel out what? X plus 1 and x plus 1. That now it's going to become, I guess if you want to rewrite it, well, it says it'll be that f of x is equal to, for this top portion here, x plus 2. Well, and we're saying that x cannot equal to -1. That's what it is. But if we plug it in now, though, in this function, if we do plug it in, x is -1, there's no problem in this function now, this one, as opposed to that one. So f of -1 is what? F of -1 is -1 plus 2. What's -1 plus 2? 1? Yes? It's 1? So it's saying then, find the value of a that will make the function continuous. A is 1. A has to equal to 1. Alright, why don't we graph it? Let's graph it so you could see what we mean by this. I'm saying that the output better be 1, because that would, whatever this, well, we're going to go into decimals, but if we graph this right here, f of x equals x plus 2, let's graph x plus 2. Well, that's y-intercept of this, y-intercept of 2. The y-intercept is 2, up 1 over 1, up 1 over 1, up 1 over 1. So it's going to go like this, the graph. But originally from here, it's not defined at -1. At x equal -1, it's not defined here. It has a hole. It has a hole. It has a hole here. So this function here, the top function is not defined. X cannot equal to -1. Well, all we did is define it, fill in the hole, and the y value that fills in the hole would be y equal to 1. That's enough. Am I going to go into? Let's go to decimals then. Let me go to decimals. So we're saying that y is equal to the original function. Y equals, what is that? X, and let me do over already. So let me go back with it. X squared. What was it? Plus 3x?
Yeah.
plus 2 over x plus 1. X plus 1. So yeah, there it is, no? Y equals this. That's a straight line. I told you it's a straight line. Now let me go into it. And here's the thing about graphs and calculators that is still not very exact in what they do, because as it is, it's dashed in. Look, it's bubbled in. It's a straight line, but it's misleading because what is it doing there at there? What is it saying? I barely got it. What is it saying? Right there, undefined. You catch it? It says undefined. Well, then why, if it's undefined, why isn't there a open there? That's why calculators are not very exact sometimes in what they're trying to do. So if we do make it defined, go back to it. Go back to it. You see it undefined? Well, it's not defined there. It's a straight line with the hole here. There it is. Oh, I can't keep it there. Keep moving around. Anyways, you define it to be 1. That's 1. And then it'll be a straight line, fully defined on the reals. All right. So that's that. And let's go to present, enter. So that's how you do this particular problem with this kind of domain. Let's go to number 2. Find values of a and b that will make the function continuous. I go to what I'm saying about having a good pre-calculus understanding makes calculus easier to understand. So this is 3 pieces. You got the first one is that y is equal to 2 for values that are less than or equal to -1. Let me move it over here more. Let me put it over here. All right. So we go like this. This is x, this is y. And I go y equal to 2. What does that look like on this graph? And you're still be like, I don't know. Anybody, what does y equal to 2 look like on the graph? One person, give it, just tell me. What? It's a straight horizontal line. It should be like, it's a straight horizontal line. So it's horizontal line at 2. This is y is equal to 2. Y is equal to 2. 4 values that are less than -1. Less than -1. Also equal to. So it goes like that. Without using a calculator. And then we could say that at 1, 2, 3, this is 3, to the right, for values that are greater than or equal to 3, it's going to be -2, okay? Y equal -2. So it's going to be a horizontal line at here, but it's going to be here and including it. Go like this. Yeah, good. Well, this will be easy. Now it says to connect it between -1 and 3, between -1 and 3, connected with a linear function. Well, I can just do it graphically and just connect them. There. What's the equation of this? See, I'm not even gonna. I will do algebra, but if I have a much better graph than this, I could kind of like figure it out without, like slope. Let's do slope. It looks to be like, so we want y equals mx plus b. No, this is y equals in mx plus b, where it's gonna be y equals m is this a, x plus b is b. Well, that one is b. It looks to be that b is this y-intercept right here. if I drew it correctly. It looks to be 1. And then the slope will be, what's the slope of this? Anybody, what's the slope of this line here? -1? That's just kind of B is 1. Well, it could be that. It could be that A is -1, B is 1. But unless you're very exact with your graphs and everything, this is just kind of like an idea of what might be, and it could be that that's true. All right. How do you do this algebra using algebra? Well, look, this is what we did on Wednesday, about knowing about left limits, right limits, continuity. If this is continuous, we go again that it is, and I am going to assume that it is continuous, then this has to equal to this at this point. So 2 has to equal to X is -1 plus B. And then on this other side, for this point, this has to equal to this right here, these two. So I'm going to say that AX plus B has to equal to -2. It's a system of equations now. See how I'm just doing? So, oh, and I should plug in what for X? What should I plug in for X? 3. Plug in X is 3 in. Now I gotta plug in 3 for this. X3, so it'll be A times 3 for this one. See how I change it? For this one I gotta put 3, and for the other one I gotta put -1. But then I have 2 equations with 2 unknowns. Goes back again to algebra. Goes back. Everything goes back. We've done the calculus. This is algebra only. So how do we do this? What do we do? Just clean it up. We can just go what? -A. Go here. So this is going to be what? -A plus B is equal to 2. This one is going to be 3A plus B. 3A plus B equals -2. Didn't we do this like second, third week of school of solving a system of equations? You can just subtract them down if you wanted to. Like you can just go what? Minus this quantity? Minus this quantity. Look, -A minus 3A would be -4A. And then B minus B goes away. 2 minus -2. What is 2 minus -2? 4. Divide both sides by -4. A is what? Come on, somebody. A is what? Am I going? A is what? -1? Yes or no? A is -1, and now how do I find B? In the alphabet? How do I find B? Plug it in either one of those equations and find B, no? So if you plug in A is -1, I'll go here. It doesn't matter. It's this here. Let's go here. So that'll be 3 times -1 is -3 plus B is -2. Add 3 if you want to do the whole. B is what? B is 1, yes? But wasn't that what I already seen what it would be? Last problem we're doing. Problem number 3. Find the value of A that will make the function continuous. So you see here, you could, let me see, let me graph it, have an idea of what I'm looking for. Erase this whole thing, let me start over. So for values less than 1, it's some quadratic thing. If I do plug in x is 1 in here, well, that makes it 0. So, and let me get another point quickly. What the heck did I say? No. What am I doing? If x is 1, this is wrong. If x is 1, what's y? If x, let me just, and I'll have it open. But if x is 1, what's the output for this? Plug in x equal 1 in here. What's the output? So it's 2, yes or no? So at 1 it would be 2, but it's open, no? It's open. Okay? So, and then let me get another point. At x equal to 0, if you plug in 0, then the output is 0. Okay, who cares? This thing is, I'm trying to get a quick picture of this thing. It's a parabola. I'm just thinking it's going like this. I don't know. Something like that. Some maybe. If we use decimals, they'll give you exactly what it looks like. How do you go? Alright. So x equal to 1. If you plug in 1 for this one here, what's the output? Somebody please. Huh? What is the output? 8. If you plug in 1, 8. So at 1 is going to be 8. And it's a line. It's going to go something like that. Without doing much work, what kind of discontinuity is this right here? A jump discontinuity. Yes? Yes? So this is going to be a jump discontinuity. But let's do it mathematically. How do you do it mathematically? Like I said, well, then if this is continuous, these better equal to each other? Or what can you do? Yeah, I mean, they have to equal each other. So if we set them equal to each other, they'll be x squared plus x equals 3x plus 5. And plug in 1. So plug in 1. Let's plug in 1. So what's 1 squared plus 1? Huh? 1 squared plus 1 is what? 1? And what's this on the right? Huh? Is 2 equal to 8? There's this one guy, he makes movies. I forget, I just read about him like 2 days ago. What the heck is his name? I forget his name. He's saying that he created some new math and that 1 times 1 is 2. He does movies. I guess more formally you would do it like this. Limit from the left. What's the limit coming from the left? And then the limit from the right. And when the two limits are not the same, then it's never going to be. There's that jump discontinuity we did already graphically.
Attention teachers, please check the route schedule. Rally B, make your way over to the gym.
Limb from the left.
Time again. Rally B,
2.
make your way over to the gym.
Limb from the right. 8. They don't equal to each other. They do not satisfy that. That's required for continuity. And we're done.